Hello and welcome back to the next topic in Kubernetes, and we are going to look at the next topic called as Helm. Okay, so let's try to understand what is Helm, what is it used for, what is the purpose, what is the benefit that we'll get when we use Helm, and when we understand all those, right? So I'll tell you the steps for how to install Helm on your machine, and then we can start working with Helm related hands-on activities. Okay, so before I tell you anything about Helm, right, you might have heard of something like package managers, right? So we have lots of package managers across various operating systems. So those who are coming from, let's say, Linux background, I'm sure you might have heard of something called apt or apt-get, especially if you have used Debian or Ubuntu based Linux distributions, isn't it? So we use apt or apt-get and then install, isn't it? That is to install new applications on our system. Similarly, those who have used Linux, which is based on, let's say, Fedora or say Red Hat or CentOS, right? You might have heard of a package manager called Yum, isn't it? So you'll say Yum update, Yum install, and of course, most of the modern day operating systems based on that family are using something like DNF. So they say DNF update and DNF install and all that stuff. Okay, so DNF is improvised version of Yum. And if you're coming to the Windows world, okay, remember we have used something called Chocolatey earlier, right? So Chocolatey, I mean, that's just one of the package managers available for Windows, using which you can install software on Windows operating system. The benefit is it's a huge list of repositories which the package managers maintain, okay, and you just have to pick up the package that you're interested in and then install it. So once you have installed it, you can update it if a new version is available, or if you're no longer interested in using that software, you can delete it. Okay, so those who are on Mac, you might recollect using something called Homebrew, isn't it? So brew or homebrew, you use that for doing package management. That means installing the software on Mac, isn't it? So similarly, you can treat Helm as a package manager for Kubernetes. That means Helm allows us to bundle all the aspects of our Kubernetes deployment in one single package. Okay, so you can treat this as a package manager for Kubernetes. So Helm is a tool which allows us to create these packages. Okay, and in terms of or in the world of Helm, we basically call that as charts. Okay, we basically call that as Helm charts. So those who might have heard about Helm earlier, maybe you might have heard about that term as well, right? Called charts, Helm charts. So Helm packages are called as charts. So what is a Helm chart? Basically, it's a collection of files that describes the set of Kubernetes resources that you want to deploy as one single unit, basically as one single package. Okay, now tell me or give me a scenario where you feel my Kubernetes deployment might end up using or creating multiple objects in a single deployment. When I say deployment, I'm not talking about Kubernetes deployment. Okay, I'm talking about maybe an application that you want to deploy in the Kubernetes cluster, right? So give me a scenario like this. Is it possible that our application can be made up of deployment plus the application might have service in it, Kubernetes service, irrespective of cluster IP or node port or load balancer, whatever, right? Or it can be ingress for the matter of fact, isn't it? So there will be a deployment, there can be ingress, maybe there are volumes, right? Volume claims, and then maybe we are using config map, or maybe we are using secrets. So I want to deploy something in my Kubernetes cluster which is using one or more of these kind of objects. So instead of maintaining them, okay, as individual deployments or individual uh, units, so what we can do using Helm is we can bundle all this together and treat that as one single package. So either you install the package or you update the package, or if you no longer want it to be there, you can basically remove it. But it would be deployed or removed or maintained as one single unit, right? So that's one big benefit of package manager. So if you remember, package manager not only installs your software, but it also installs all the dependencies, isn't it? So if on Linux world, when you say sudo apt install and you give the package name, it will install all the dependencies which are needed to run that package, right? Now that is what is Helm in terms of Kubernetes. It's a package manager. Just to make you understand this easily, so for example, if I want to install, let's say, MySQL server on a Debian or Ubuntu based machine, I will say apt install or apt get install, whatever. Okay, there is a slight difference between them, but the overall purpose remains the same. Okay, so you can say apt install MySQL, or you can say yum install MySQL. Okay, like that. So equivalent in Helm would be Helm install. Okay, that would be the application name, the Helm deployment name, and what chart would you like to install, or basically what application would you like to install. Okay, something like this. So similarly, if you want to update the existing package, so you say sudo apt update, right? So in Helm it will be upgrade, just to make you compare and understand the analogy there. So we have install activities, we have upgrade activities, like that. So it's basically about packaging Kubernetes applications as one single unit and deploying them. Now, does that mean we are no longer going to use the utility or the Kubernetes client called kubectl, right? What we popularly call it as kubectl. Does that mean we are not using it, or we are eliminating the requirement of it? Does it mean like that? What do you say, guys? So when we use Helm, we don't have to directly use the kubectl command at all. So basically Kubernetes CLI is bypassed. Bypassed in the sense we are not using it. And through Helm, if you look at the figure carefully, right? Through Helm, our requests directly go to the API server. You know what's the significance of API server in the cluster, right? So it directly goes to the API server, which in turn results in creating of the various objects in our cluster. Okay, so based on what is packaged in your Helm application, so the deployments, the services, the config map, secrets, whatever you need are absolutely created through Helm. Okay, that's the concept. And when I say Helm packages are maintained in something called charts, not only it can maintain the information of the old charts in case you do any modifications, right? And you want to upgrade the existing deployment, right? Now we end up having something called new charts. So Helm maintains old charts, new charts. It has the information about what is right now currently deployed in the cluster. And because of that, it is able to basically upgrade. Okay, so basically it can do something like what we say patch management. Patch is basically a small rectification job that you want to do in a software in case there are any critical security loopholes or bugs detected. We say we are patching the application, isn't it? If you have noticed, certain software vendors do release something called patches. So what do you mean by patches? Whatever problems that have been detected, they will be basically rectified in the patch release. So Helm allows us to patch the existing applications. For that, it keeps track of the old charts. It knows what are the changes that you want to do, because it can look at the new charts and it knows the differences. So it can do the differential update. Okay, that is what we call it. We call it as a differential update. So how does actually Helm maintain all the information about the objects? Okay, it is in the chart. And how is the chart expressed? We are able to express it because Helm itself internally has a templating engine. Okay, now using that templating engine, we can describe our Kubernetes objects in the form of something called manifest. Okay, now if you are hearing this term for the first time, don't worry. The Kubernetes YAML files are a kind of manifest, okay, which describes what objects that you want to have in your deployment. Okay, so when I say Helm is a kind of a templating engine, so what does it allow us to do? Using that templating engine, we define a common blueprint, a template for multiple YAML files. And now that you have a template, Now based on the template you can create as many objects as you need. Okay, so in a template we can insert the values dynamically because a template will have something called placeholder. Okay, so templates will be having, okay, placeholders, and values for the placeholders will come through something called values.yaml file. Okay, I'm sure because most of these things are new for you. Okay, so just try to concentrate and listen to the video again. So when you say template, it basically tells you the model of the object that you wish to deploy, and then through values, okay, we insert what has to be inserted into the template. So we have something like a template YAML file, and we also have something called values YAML file. So values will specify what will go into the template. Okay, for example, if you look at the figure on the screen, right, so on the right hand side it is written as template YAML file, isn't it? Now if you notice, this will be very similar to a Kubernetes YAML file which is familiar to most of you. In case you are regularly attending and practicing, it will be very similar to a Kubernetes YAML file. Okay, so maybe if I can quickly show you, okay, a particular YAML file from our earlier deployment, right? Let me just take that to you guys. So I'll go to our old regular folder. Okay, that was temp2 Kubernetes demo, and let me open that folder in VS Code. Okay, that's all the YAML files that we have seen so far. Okay, but this is not the only list. We have few more in my Linux machine. Okay, you know that. So let me open a YAML file which maybe allows us to create, let's say, a pod. Okay, there you go, a YAML file which allows us to create a pod. So I want you to look carefully at that YAML file. Okay, so we have the kind of object that you wish to create, that's called pod. What will be the name of the pod? Okay, and then what will be the container specification which will be created in the pod. So what will be the name of the container, and the container will be based on which image. So are these all the real values which are in turn used by the Kubernetes cluster? What do you say? Are these the real values? Like the pod, the kind of object is pod. Okay, what will be the pod name, right? What will be the container image name? What is the container name? Are these the real values which are used by the Kubernetes cluster? Isn't it? But when you create something like a template, a Helm template, you notice carefully, these don't have the real values to be used by the cluster. Okay, rather we have placeholders here. I'm just talking about this file. There you go, the template YAML file. What we have here are the placeholders. Okay, so this is a YAML file for creating a pod. So what will be the name of the pod? We haven't specified here. Why? Because this is just a template on which a pod will be created. The value will be specified at the time of installing or deploying. Okay, so values will come from the value template file. Okay, so it comes from values.name. Similarly, the container name, the container image name, the container port, okay, where we wish to run the application and expose to the clients, isn't it? All these are the placeholders. So I can see there are 1, 2, 3, 4, right? I can see there are 4 placeholders. So this is just a template, and this is how you create a template in Helm. Okay, because Helm basically is a templating engine by itself, right? So through that templating engine, we actually create a template, and the values will be specified in the values file. So for example, you look here, this is the values.yaml file. So the values will come from that values.yaml file. Okay, so, and of course this insertion of values from values.yaml into template will happen dynamically. That means just before the deployment. Okay, so remember, in the template we had 4 placeholders, right? Values.name, container.name, container, isn't it? So all these are actually coming from here. There you go. So we have name, so values.name. Okay, then we have name. So that comes from container.name. See how it is related. So on the left hand side, if you look in the values YAML file, right, on the left hand side, so name, image, port are under container, correct? Name, image, port are under container, whereas name of the pod is at top level. Okay, so that's at the top level. Now something which is at the top level is directly coming from the values YAML file. Okay, there you go. It's directly coming from the values YAML file. Whereas other values which are not at the top level in the values file, we have to specify their nesting composition. So name, image, port are under container. That means they are nested, isn't it? And that nesting aspect is what we have to specify. So the value for this comes from here, right? So values, that's your values YAML file, dot container. So there should be a section called container. Under that there should be an entry, or there should be a property called name, and whatever is the value for name, that will be inserted in this placeholder. Okay, so values.container.name. I hope you understood that. Similarly, we have values.container.image, values.container.port. Okay, so they are coming from this nesting: container.name, container.image, container.port. There you go. And where is container? Container itself is in the values YAML file. It's at the top level. Okay, so there are two top levels. One is name, other is container. So values.name, values.container. And nested inside container are some more properties: name, image, port. Okay, so like this, Helm will insert values into the template dynamically. Now what is the benefit of doing something like this? The benefit is we can reuse the same template with different values. What do you say? You agree to this? So the benefit that I was talking about was we can basically reuse the same template multiple times, isn't it? That would be one big benefit. Now not only Helm, okay, is a package manager for Kubernetes deployments. Okay, when I say deployments, it's not Kubernetes deployment kind of object. I say application that you wish to deploy in the cluster. Okay, I'm calling that as deployment. Basically from the software perspective. Okay, from the software industry perspective, we have a term called deployment, isn't it? I'm talking about that word called deployment, not the Kubernetes object called deployment. Okay, so it is a package manager, it is a templating engine, right? It also is used for release management. Okay, so what do you mean by release management? So maybe you have a particular version of an application right now deployed and running. Okay, so maybe you have certain application which is evolving by nature. So when I say it is evolving, that means there would be certain changes. Okay, so and how do you basically manage the different versions of the application, right? Now this is what we call in the industry as release management. So Helm also allows us to do release management for our Kubernetes applications. So in Helm word, release implies it's basically the current deployed and the running instance of the chart. Okay, that is what we call it as release. Whatever right now you have deployed in the cluster, so that's the current representation of the chart in the cluster. So we call that as release. Okay, a running instance of the chart in the cluster is release. And of course, a running instance always has certain configuration associated with it, isn't it? And then the configuration contains all the information that can be merged into a chart, which can be packaged together, and that is what is basically released for deployment. Okay, so when I say it is a package manager, right? When I say Helm is a package manager, so the package manager requires certain configuration, isn't it? Not just Helm. If you look at any package manager, it needs certain configuration, right? So associated with the chart will be configuration. So based on the information which is there in the configuration, okay, all your stuff to be deployed is packaged, and then it would be released for deployment. Okay, and how do you release it? Obviously that is where we basically have the commands, the Helm commands. Like the commands would be, okay, there you go, Helm install, Helm upgrade, Helm rollback. So this is where basically your config will be utilized. Okay, So as you can see, there are lots of stuff to discuss before we can actually lay our hands on Helm, isn't it? So lots of interesting things to discuss. Right, so the configuration, you understood the significance. Let's continue further. Helm also keeps a track of the release history of all the deployed charts. Now why it keeps a release history? So that if you want to revert, if you want to roll back to any specific version, right, you can always roll back. Got it? So there are appropriate commands for doing that. There you go. Helm rollback. Okay, and you can give a specific release or version information, and we go back to specific release. Why do you want to roll back? Because maybe a new release has caused some problem, maybe some unexpected issue has cropped up, and maybe you want to revert back to the previous working version, right? So that is where the rollback concept comes into picture. So does Helm allows us to roll back? Yes. Okay, how come it does that? Because it keeps track of all the releases that you have done. So does this strike something in your mind? Do you remember doing something like that in Kubernetes? It keeps track of the releases, and we can go back to a particular release. Since we know what application versions have been installed, we can always roll back, okay, and revert to a particular version, okay, maybe the particular working version of the application. So these are some of the important aspects of what Helm can do. It is a package manager. It can act like a templating engine, okay, which allows us to maintain templates for our Kubernetes objects, and it also can be used for release management, okay. So packaging, deploying, managing those deployments, and also templating, okay. So all these things put together will make Helm quite powerful to work with Kubernetes. Remember, very important and critical aspect, Helm is built on top of Kubernetes, okay. So the purpose of that is to actually make our life easier when your Kubernetes objects has lots of, Kubernetes deployment has lots of objects, okay. We want to package them together as one single unit. It's not that you will write n number of YAML files, okay, put them in a directory and then give that for deployment, isn't it? So, but then your deployment will not be identified with a particular version. You have to keep track of your individual YAML files, and in case any YAML file has been modified, you have to apply, isn't it? kubectl is intelligent enough to detect the changes with respect to what is right now in the live cluster and what is desired, and it will make the current same as the desired one, isn't it? But if I want to do that at an application level and not at a single YAML level, okay, so Kubernetes allows us to, Helm allows us to do that easily. So it basically simplifies the life of a Kubernetes developer and administrator, okay, as simple as that. And because it's trying to simplify our life, sometimes it gets a bit complex to understand its features, isn't it? Like for example, you can always assume that when I want to go from place A to place B, I will walk, and you assume that it's quite simple, isn't it? But if you want to save your time and you want to go from place A to B, let's say on a vehicle, right? You want to, let's say, go by a car, and obviously you have to learn now how to drive a car. So in the initial days, it might appear to be a bit complex issue, okay. I'm sure those who learned how to drive a car, you know what kind of efforts you might have put, isn't it? Yeah, of course, after you learn how to drive a car, you can as well, okay, close your eyes and tell which control is at which place in your cockpit, isn't it? You know where is the facility for the accelerator, where is the brake, how to work with the air conditioner, where are the music player controls, isn't it? You know everything what is there in the car. But while you were learning, right, we learned one thing at a time, isn't it? How to move it forward, how to move it backward, how to turn left, how to turn right, isn't it? And then you learn what are the controls of the music system. You learn what are the controls of managing the air conditioner in the car. You learn one at a time, and then later you can do many things at the same time because it appears to be a repetitive and familiar task, correct? Same is the case with Helm as well. Because we are taking one concept at a time, so it might appear, oh, there are so many things to learn. But once you learn and get hold of the concepts, okay, trust me, it is something which would be highly appreciated, and you will never go back to directly running the commands through kubectl. I mean the create the objects through kubectl. Okay, yeah, Helm, yes, is third party but is open source, and because it is open source, okay, it can be trusted, and because of it is open source, basically community contributes a lot to it, and whenever community contributes there will be lots of changes, and those changes are always for the improvement, right? And the industry has actually wholeheartedly accepted Helm as something which has to be used if your Kubernetes objects is huge by nature. Okay, if your Kubernetes objects, I mean if the Kubernetes deployment is just one or two or very few single digit YAML files, okay, you might not appreciate Helm at all. But if it becomes complex, yes, then you'll appreciate something like Helm. Okay, like for example, walking is always simple, but if you have to go for a far distance, then you'll appreciate the significance of having a vehicle. Okay, right. So that is what is the facility where you should start appreciating Helm in. Okay, for the betterment. So what can Helm do? It can create charts from scratch. Okay, so I'll take a quick knowledge check. What is a Helm chart? Right?